Hello friends, welcome to my channel Physics Moji. In today's video, we are going to discuss the refraction of light activities part 3. So we are going to discuss Snell's law in this activity. Now first we will see what is Snell's law. Snell's law states that the ratio between sine of angle of incidence to sine of angle of refraction remains constant. That is, sin I by sin r is a constant, and that constant is represented by n, where n is called the refractive index of the given pair of media. So the aim of the activity is to prove Snell's law, that is sin I by sin r is a constant, and we will also prove that the light bends towards the normal when it travels from a rarer medium to denser medium, and the angle of refraction is less than angle of incidence. The apparatus required for this activity is a protractor circle, a white chart, a plank, a pencil, laser light, and a semicircular glass disc of thickness nearly 2 cm. Let us go into the activity. So our activity is to prove Snell's law. So for this activity, we need a protractor circle, a semicircular glass disc, a laser light, a pencil, and a scale. Now let's see the procedure of the activity. Now take a white chart and draw two perpendicular lines from the middle of the page such that both of them will intersect at a point. Let the intersection point be O. Let the horizontal axis, the horizontal line be named as MM, and the vertical line be named as NN. Now take a semicircular glass slab and place it on the interface line MM such that the center of the glass slab should coincide with the intersection point O, and draw the outline of the semicircular glass slab. Now take it out. Now invert the semicircular glass slab and draw the outline. And take the semicircular glass slab from the position. Now mark the angles by using a protractor circle. So you can observe the angles are marked from 0 to 90 on positive xy axis and negative xy axis. Okay. Now place the semicircular glass slab on the interface. And before conducting the activity, I will discuss an important thing. If you observe the diagram, the blue color light is the incident light. So the green color ray is the refracted ray. And if you observe the red color ray, it is the reflected light. Okay. So when the light ray is getting refracted, some of the light is getting reflected. So please make a note of it. So along with the refraction, some of the light is getting reflected into the same medium. So here if you observe, it is traveling from rarer to denser, bending towards the normal. Now if you observe this picture, you can observe that the light ray is traveling from denser to rarer such that it bends away from the normal. And you can observe here that the red light is reflecting into same medium. So the reflection, some of the light will get reflected into the same medium during the refraction, but we will not take them into account. So when the light ray travels from one medium to another medium, some of the light can also be reflected into the same medium. Now let's move on to the activity. So I incident the light along the normal. We know when the light ray is incident on normal, no refraction takes place. So it goes in a straight line. Now I have been incidenting the light at an angle of 10 degree. You can observe that some of the light is getting reflected into the same medium and some of the light is coming out from the other side of the semicircular glass slab. Next, after 10 degree, I am trying to incident the light at different angles. You can observe that when the light ray is incident at an angle, some of the light is coming back into the same medium, some of the lighting is coming out of the glass slab. Now I have increased the angle of incidence. Now if you observe, again some of the light is getting reflected and some of the light is coming from the other side of the glass slab. Now I have incident at an angle of 30 degree. So you can make the same observation again. Okay. So now let us see how the light travels in air. So if I incident the light in air, let us see how it travels. When I incident at an angle of 10 degree, it is coming out at an angle of 10 degree. So according to Fermat's principle, we know light travels in a straight line, rectilinear propagation of light. So when I incident at 30, it comes at an angle of 30 degree. So in a medium, the light travels in a straight line. But when the glass is placed, and if you observe, I am incident at an angle of 30 degree. If you observe the angle of refraction, it is less than 30. Okay, so from here we have proved that the light ray will bend towards the normal when it travels from rarer medium to denser medium. So the light is traveling from air to glass, that is rarer to denser. So it is bending towards the normal, and the angle of refraction is less than angle of incidence. These values of angle of incidence and angle of refraction are tabulated in the given table. So in the table we contain the angle of incidence, the angle of refraction, the sine of angle of incidence, the sine of angle of refraction, and the ratio between sine and sine r. So we will note down the angle of incidence and angle of refractions here, and we will find the sine of every angle of incidence and sine of every angle of refraction, and we will find the ratio of sine I and sine r. So if you observe the table, you can see the angles of incidence and the corresponding angles of refraction. So we have found the sine values for every angle of incidence and sine values for every angle of refraction. Now if you observe the ratio between sine I and sine r, you can see that in the last column the values are constant. So they may not be exactly equal, but they approximately they will get a value of 1.33. So from this we can say that sin I by sin r is a constant. So our intention, our aim is to prove that the ratio between sin I and sin r is a constant. That constant is nothing but n. So where constant is nothing but the refractive index of the material. This constant is called refractive index. So you can calculate by using these values. You may not get the exact values, but you can get approximately the same values. Finally, we can conclude that the Snell's law has been proved, and we observe that the light bends towards the normal when it travels from rarer medium to denser medium. And we also observe that the angle of refraction is less than angle of incidence when the light ray is traveling from rarer medium to denser medium. So that is the conclusion of the activity. Thank you friends for watching the video. Hope this is helpful for you, and I hope you like it, and we'll meet with the next activity, that is refraction of light activities part 4. Please support my channel, like, share and subscribe to my channel. Thank you.